Assalamualaikum and hello everyone. My name is Nur Ain Azwina binti Ali Abbas with student ID 2019-257-392. I am from group 3A4A. I choose to conduct Metacentre height experiment. The objective of this experiment is to identify the position of the metacentre of a floating body by determining its distance from the center of gravity. Now, let's move on to theoretical background. For static equilibrium of puntun, the total weight W, which acts through the center of gravity G, must be equal to the buoyancy force F, which acts through the center of buoyancy P, which is located at the centroid of the innermost cross-section. When the puntun heels through a small angle, the metacentre M is identified as the point of intersection between the line of action of the buoyancy force. It is always vertical and BG extended. For stable equilibrium, M must be above G. Adjustable position traverse weight experiment. Both of the center of gravity G and center of buoyancy B will shift to a new position when traversing weight is moved to one side. Since the shift in the center of gravity was caused by moving the weight P through a distant x, then we got the first equation. From figure A, we got the second equation, and then substitute question 2 into question 1, and then we got Gm equal to Px over W tan theta. Based on geometry and depth of immersion, the metacentric height Gm is defined as Gm equal to Bm minus Bg. The metacentric radius Bm can be defined as Bm equals to I subscript G of V, where I subscript G equals to Lb power of 3 over 12. The immersed volume V can be found from V equal to L PdI subscript I. Since we were not allowed to be in campus due to restriction by movement control order, we were asked to conduct in-house experiment with suitable apparatus we can get. The apparatus that I chose according to suitability and creativity are plastic container, thread, screw, ruler, protector, small weight, sellotape, cable tie, baby path, basic. And here is the model based on my creativity. Let's watch the procedure. Hi everyone, the first thing that I do is weigh the small weight. Secondly, I measure the length, width, and the height of the plastic container. Thirdly, the model is assembled and weighed to get the total weight. Next, determine the position of G and measure the distance of G from the base of the model and record the distance as y. After that, fill the baby bath basin with water and float the metacentric height model in the basin. And record the immersed depth. Put the weight to the right in 4 cm increments to the end of the scale and record the angle of heel. Then, change the distance with differences of 4 cm and do the same procedure with different positions. This is the data that I obtained from the experiment. Discussion. Based on the data obtained, we can identify the position of Metacentre M by adding the distance from base to the center of gravity G and experimental GM. We know that in order to get stable equilibrium, Metacentre M must be above or equal to center of gravity G. Since the value of G is 0.11 meter, then the result that we obtain is stable equilibrium because all the results of M are higher than G. There are few errors may occur during this experiment which are parallax error. The person who takes reading may read the value wrongly. Next, the water was not in steady condition and create wave while taking reading. Lastly, the error of noting down the angle. Lastly, conclusion. In conclusion, the metacentric height GM is a measurement of the initial static stability of a floating body. Thus, the objective of this experiment is achieved.